Good morning, this is your Stat Sensei, Mr. Spensei, and this is a chi-square test of independence warm-up on, and our scenario is lost cause. The Colorado Rocky Mountain Rescue Service wishes to study the behavior of lost hikers. If more were known about the direction in which lost hikers tend to walk, then better search strategies could be devised. 200 hikers selected at random from more than 200,000 applying for hiking permits. All right. So we have a sample size of 200, and we know that that's going to be important. So I'm going to go ahead and mark this off to the side. N is 200 out of a population of 200,000. So we have a population right here of 200,000 applying for hiking permits are asked whether they would head uphill, downhill, or remain in the same place if they became lost while hiking. Each hiker in the sample was also classified according to whether he or she was an experienced or novice hiker. The resulting data are summarized in the table below. So it says, when we read this, it says each hiker in the sample. All right. And my understanding of the word the in English is that means that's only one thing, one group. So we have one sample, and that was one of the questions. It says calculate the expected values and give the number of samples. All right. Well, I see that there's one sample, but they were measured on two separate things. And because they were measured on two separate things, that means we have two variables. And our variables are going to be direction is one. That's going to be one of the variables. And the other variable is experience. Well, when I look at direction, I could go one of two, I can go one, two, or three different levels. So that direction has three levels. And when I look at experience, I go, oh, you can either be novice or you could be experienced at it, in which case we have two levels. All right, and that's going to be useful for finding our degrees of freedom, because even though it didn't ask for this, we might as well look at it right now. Degrees of freedom equals rows minus one times columns minus one. Well, that's going to be two minus one, because we have two rows, and we have one, two, three columns. So that's going to be three minus one. So this will go to one, this will go to two. One times two is two. So our degrees of freedom in this case is equal to two. All right, it asks us to calculate the expected values. And the way to do the expected values for a test of independence is to go to the matrix, which means we're going to press blue button, and this is the x squared. And that, oops, I'm sorry, blue button and the button right here, x negative one, and it says matrix right above it in blue. And we're going to go over to edit, press enter. It's like, well, what do I have? I have one, two rows, one, two, three columns. The same thing we used to get our degrees of freedom. We went two, enter, three, enter. All right. And now we're going to put in our observed values, which are 20, 50, and 50. And then 10, 30, and 40. And I'm going to blue quit. Then I'm going to go blue button. Now that I've done that, I can go ahead and run my test, stat test. It's not a goodness of fit. We're doing a chi-square test of independence, so we want just plain old chi-squared, which is letter C. And we're going to go A, B, and calculate. And we get all this information that's great, and then it confirmed our degrees of freedom of 2. We got a p-value of 0.47, which is very big, so we're not going to reject. But we still don't have our expected values. To do that, we have to go back into the matrix. So we're going to press blue button matrix, drop down to letter B, and go to edit and now drop down to letter B. So you know what? I'm just gonna say arrow over to edit, then hit B, and we end up getting our expected values, which are 18, 12, 48, 32, 54, and 36. All right, that's our warm up, and this will be in our note spiral. Appreciate you watching. Look forward to seeing you on the next one. Thank you.